Hello there, and welcome to Deep Space Sleep. I'm glad you're here. Maybe your day felt crowded with noise and expectations, and now you're searching for a place where everything finally slows down. Or maybe you're someone who finds peace in the forest in knowing that moss grows whether we hurry or not, that moisture gathers on quiet mornings, and that calmness can be found simply by looking closely at the small green worlds beneath our feet. Either way, this moment is for you. There's nothing you need to solve or carry. Let the forest soften around you. Let your breath lengthen and settle, as if you're walking through a shaded woodland where cool air drifts between the trees and gentle moss cushions glow beneath filtered light. The bryophytes around you aren't busy or demanding. In this video, we're exploring the quiet life of bryophytes, not complicated classifications or scientific detail, but the subtle motions and soft structures that fill the forest with tranquility. The way mosses absorb dew drop by drop, the way liverworts press like green lace against bark, the way tiny sporophytes rise slowly toward the dim canopy light, the quiet resilience, the drifting spores, the miniature landscapes that form in silence. You'll hear 100 gentle facts. Some about mosses you've seen without noticing, others about the hidden processes that make bryophytes glow, breathe, and hold the forest together in such peaceful, steady ways. If this brings you rest, you're welcome to subscribe whenever you wake. It helps others find a calm moment too. For now, let the forest open quietly around you. Let the green deepen. Let the small things become enough. Let's begin. The first land plants rising from ancient water began their quiet story hundreds of millions of years ago. Long before forests existed, before roots carved through soil or leaves reached toward the sun, early bryophyte ancestors crept slowly onto bare rock near the edges of ancient seas. They absorbed moisture directly through their tiny surfaces, anchoring themselves with delicate filaments instead of roots. These small, simple plants laid the groundwork for every future ecosystem, capturing sunlight in places that had never known green. Rain pooled around them, forming thin, glistening films that helped them grow and spread. Wind carried their spores across stone, creating soft patches of life in an empty world. In their stillness, they began transforming rock into soil, preparing earth for the forests to come. Over ages, their descendants evolved into the bryophytes we see today, plants that still carry this ancient calm. Bryophytes, as living fossils unchanged for ages, remind us how deeply their lineage is rooted in time. While other plant groups evolved towering trunks, thick leaves, and complex vascular systems, bryophytes retained their simple structure: tiny leaves, slender stems, and a humble reliance on water. Their life cycle still mirrors ancient patterns, with the gametophyte remaining dominant, just as it was hundreds of millions of years ago. They survived ice ages, shifting continents, and mass extinctions not through strength, but through patience and adaptability. Their bodies dry completely, then revive with the first touch of moisture. Their spores drift effortlessly through wind currents, colonizing new places just as their ancestors did. This ancient stability connects them to the earliest chapters of terrestrial life, guiding us naturally toward the way mosses adapted to every continent except the sea. Mosses adapting to every continent except the sea reveals their extraordinary resilience. They thrive in Arctic tundra, tropical rainforests, mountain ridges, stream banks, deserts, and urban concrete, anywhere moisture occasionally touches the ground. Their poikilohydric nature allows them to dry out for months, even years, and awaken again the moment they receive water. Tiny leaves overlap in spirals that channel moisture inward, while rhizoids anchor them lightly to soil, bark, stone, or decaying wood. They endure cold by forming tight cushions that trap warmth and survive heat by shrinking into protective curls. Because they lack true roots, They rely on rain, fog, and dew, making them incredibly adaptable to unstable environments. This global presence sets the stage for the next quiet transformation. How tiny forests emerge from bare rock and bark. Tiny forests emerging from bare rock and bark show how bryophytes act as nature's earliest architects. When a single spore lands on stone or tree bark, it germinates into a thin, soft green film. Over time, that film thickens into cushions, mats, or branching shoots, forming miniature landscapes with valleys, peaks, and shaded hollows. These microforests trap water, soften surfaces, and create shelter for springtails, mites, small worms, and microbial life. As the moss grows, it slowly breaks down rock particles through chemical weathering, collecting dust and organic fragments to form the earliest layers of soil. On bark, moss creates pockets of humidity that nurture fungi and insects. These small worlds reveal how bryophytes turn lifeless surfaces into thriving ecosystems. And at the heart of this quiet transformation lies their unique life cycle, one shaped by the dominance of the haploid gametophyte. Haploid gametophytes, shaping bryophyte identity, give these plants a life rhythm unlike most others. In bryophytes, the gametophyte, the green, leafy plant we see, is the main life stage, carrying a single set of chromosomes. It performs photosynthesis, absorbs water, and produces the reproductive organs that depend on moisture to function. When conditions are right, sperm swim through thin films of water toward egg cells nestled at the tips of tiny shoots. After fertilization, a sporophyte grows directly from the gametophyte, lifting its capsule into the air on a slender stalk. This structure produces and releases spores, beginning the cycle again. This simple yet elegant system has persisted across ages, helping bryophytes thrive where more complex plants struggle. From this ancient pattern, the next chapter unfolds how these tiny forms continue shaping the quiet landscapes of Earth. How bryophytes thrive without true roots reflects their remarkable simplicity and adaptability. Instead of drawing nutrients from deep soil, bryophytes absorb water and dissolved minerals directly across their leaf surfaces. Their tissues are thin, allowing moisture to spread quickly from one cell to another like a slow-moving ripple. This direct absorption lets them live on tree trunks, stones, decaying logs, and even concrete places where rooted plants could never survive. Because they don't depend on soil depth, they flourish in tiny crevices and shaded hollows where only mist or raindrops can reach. Their survival depends more on humidity and gentle moisture than on complex structures. When water touches them, they respond instantly, swelling into soft green carpets. This simple strategy allows them to colonize nearly any surface, a process supported by the next quiet feature of their design, the rhizoids that lightly anchor them to the world around them. Rhizoids anchoring plants to soil, wood, and stone act like delicate threads tying bryophytes to their environment. Unlike true roots, rhizoids don't transport water. They serve mainly to hold the plant steady against wind, flowing water, or passing animals. These fine filaments weave into tiny cracks in bark or rock, gripping the surface with a gentle, persistent touch. Rhizoids help mosses cling to vertical trunks, drape over boulders, and spread across fallen logs. As they anchor, they also trap dust, organic fragments, and moisture, gradually creating a richer substrate beneath the moss. This slow accumulation of material prepares the ground for seedlings, fungi, and microorganisms that follow. The moment water arrives, whether from rain, fog, or dew, these anchored colonies come to life, awakening through their poikilohydric bodies that respond instantly to moisture. Poikilohydric bodies, awakening with rain, demonstrate bryophytes' extraordinary ability to dry out completely and revive again. When moisture disappears, their leaves curl inward, chloroplasts retreat into protective positions, and metabolism slows, almost to a stop. They look lifeless, brittle, and dull. But the moment water touches them, whether through a raindrop, a passing mist, or morning dew, their cells rehydrate in minutes. Leaves unfurl, pigments brighten, and photosynthesis resumes with quiet certainty. This reversible transformation allows bryophytes to survive droughts, heat, and long periods of exposure. The forest floor often changes from brown to vivid green within a single gentle rain. These awakenings create new bursts of activity in moss layers, offering vitality to the microhabitats forming on trunks, roots, and stones where countless tiny creatures live. Microhabitats forming on trunks, roots, and stones arise wherever bryophytes spread like soft green tapestries. Each patch becomes its own world, with humidity, shade, and temperature patterns far different from the surrounding air. Thin layers of overlapping leaves trap moisture, creating safe hiding places for springtails, mites, beetle larvae, snails, and countless microorganisms. On stones, moss cushions soften rough surfaces and form shallow basins that collect rainfall. On roots, they create narrow green corridors that guide insects through dim forest light. On trunks, moss mats become moist stairways for small invertebrates climbing toward the canopy. These micro-worlds teem with quiet life, much of it unseen, unless viewed through a magnifying lens. And inside even the smallest moss cluster lies an entire community, proof that forest biodiversity can be hidden inside fragments no larger than a coin. Forest biodiversity hidden inside moss fragments shows how essential bryophytes are to entire ecosystems. A single pinch of moss may contain dozens of species, from microscopic rotifers to graceful springtails and specialized fungi. These fragments serve as nurseries, feeding grounds, and shelters for organisms that depend on constant moisture. Spores from fungi settle within moss cushions, seeds lodge between tiny leaves, and bacteria flourish in the stable humidity. As moss grows and decomposes, it builds the first layers of soil that larger plants depend on. Birds gather moss for nesting, amphibians hide within it to avoid drying out, and insects forage in the shaded crevices it forms. This hidden diversity contributes to the resilience of forests, creating networks of life that begin in places small enough to overlook. And from these small beginnings, the calm story of bryophytes continues into the next gentle chapter of their world. Capillary wicking lifting droplets through moss leaves is one of the quietest and most elegant movements in the forest. Each leaf has thin spaces where water slips upward, defying gravity through cohesion and adhesion. A single droplet touching the tip of a moss cushion can rise millimeter by millimeter, spreading through the plant like a slow breath. This wicking action allows mosses to hydrate fully from the faintest rainfall or even the brief brush of mist. Within minutes, entire patches swell with moisture, turning matte textures into gleaming green. Because water travels so efficiently through these tiny capillary spaces, mosses can thrive on vertical trunks, rough stones, and fallen branches with little soil. This silent upward movement becomes the foundation for how bryophytes store, transport, and release water. It guides us naturally to the way these carpets hold rainfall within the forest. Bryophyte carpets storing forest rainfall like sponges reveal one of the most essential ecological roles of mosses. Their layered leaves create small chambers that trap water, holding it far longer than bare soil or leaf litter could. During storms, moss cushions absorb vast amounts of moisture, preventing quick runoff and allowing the forest floor to remain evenly damp. As the weather dries, they release this stored water slowly, offering a steady supply to seedlings, fungi, and microorganisms living nearby. In some ecosystems, such as coniferous forests and peatlands, bryophytes can hold several times their own weight in water. These natural reservoirs moderate temperature and humidity, softening the microclimate for countless species. And when the rain clears and the droplets settle, the forest awakens to new moisture sources drifting quietly through the air, leading us into the gentle world of dew and fog. Dew and fog, becoming gentle sources of life, show how bryophytes depend not on heavy rain, but on the softest forms of water. Their surfaces are perfectly shaped to capture tiny droplets suspended in morning mist. As fog moves through the forest, each filament and leaf gathers moisture like a fine net. Dew settles overnight, forming beads that slide into the moss layers at dawn. These subtle water inputs can sustain moss mats during long dry periods, especially on ridges, tree trunks, and exposed rocks. The slow absorption of dew offers hydration without saturation, allowing photosynthesis to resume early in the morning. Fog-fed moisture also creates ideal conditions for delicate processes like spore development and gametophyte growth. And with each drop absorbed, the bryophytes prepare for the next stage of their reproductive cycle, where water forms a thin, essential film. Water films enabling moss reproduction highlight the deep connection between bryophytes and moisture. Unlike most land plants, mosses rely on a thin layer of water for fertilization. Male gametes swim across these films to reach female structures, making rain, dew, and mist essential to their life cycle. When conditions are right, the forest floor becomes a quiet, shimmering landscape where microscopic movement begins. These films coat leaves, stems, and tiny channels between moss cushions, turning them into pathways for life. Even brief humidity spikes can trigger reproductive events, ensuring species continue in unpredictable environments. The presence of water films also supports microbial communities that coexist with mosses, strengthening their health and nutrient flow. As this reproductive dance unfolds, the water eventually drains downward, moving through moss layers that gently filter and purify it, preparing it for the next forest stage. Rainwater purified as it passes through dense moss shows how bryophyte layers act as natural filters in the forest. As droplets move downward, they travel through overlapping leaves and microscopic chambers that trap impurities and particles. Moss cushions slow water movement, allowing sediments to settle and organic fragments to be absorbed. In some environments, mosses even capture pollutants, acting as quiet guardians of water quality. The water that emerges beneath a moss mat is often clearer and cooler, contributing to clean seepage that nourishes roots, fungi, and soil organisms. This natural filtration process supports entire ecosystems, especially in high-altitude forests and peatlands, where mosses dominate. With each drop refined and released, the bryophytes continue shaping the forest's hydrological calm, leading us into the next gentle chapter of their quiet, green world. Moss blankets cooling the air through evaporation create a quiet form of climate moderation on the forest floor. When moss absorbs water, some of that moisture later evaporates slowly from its surface, drawing heat from the surrounding air and lowering temperatures by small but meaningful amounts. This cooling effect is strongest in dense moss carpets, where thousands of overlapping leaves create a broad surface area for evaporation. On hot days, the ground beneath moss stays noticeably cooler and damper than exposed soil. In shaded forests, this gentle evaporation helps maintain a stable microclimate that benefits insects, amphibians, and seedlings sensitive to heat. When the afternoon sun filters through the canopy, the cool air rising from moss cushions mixes with drifting shadows, creating soft pockets of refreshing calm. And on the moist surfaces of nearby liverwort thalli, another kind of quiet interaction with water unfolds. Moisture clinging to liverwort thalli reveals one of the oldest plant-water relationships on Earth. Liverworts have smooth, often glossy surfaces that hold thin layers of water like a delicate film. These films allow for gas exchange, photosynthesis, and reproduction in conditions where other plants would struggle. The texture of the thallus, flat, lobed, and close to the substrate, helps capture droplets from dew and fog. When touched by morning light, these tiny, shimmering layers look like liquid glass spread across the forest floor. This captured moisture supports microfauna living among liverworts, including rotifers, nematodes, and fungi. When dry periods arrive, the thalli curl or shrink slightly, conserving what little moisture remains. But even after losing nearly all water, bryophytes hold a remarkable ability: the power to revive after complete desiccation. Bryophytes reviving after complete desiccation is one of nature's gentlest miracles. When water disappears, mosses and liverworts enter a suspended state, their cells folding inward and metabolism slowing to near zero. They may appear brittle, faded, or lifeless for weeks or even months. Yet the moment water returns, whether a passing shower or a bead of dew cells rehydrate almost instantly. Pigments brighten, leaves uncurl, and photosynthesis resumes as if no time has passed. This remarkable resilience, known as poikilar hydry, allows bryophytes to survive environments where moisture fluctuates drastically. In forests, this revival creates a wave of green that can transform dry patches into vibrant carpets after a single rain. As bryophytes reawaken, they also release moisture slowly into the air, shaping the broader forest's humidity. Forest humidity, shaped by moss cushions, forms a quiet, stable layer of moisture that influences countless organisms. Mosses hold water within their structures and release it gradually, increasing humidity near the ground even during dry periods. This soft moisture creates ideal conditions for fungi, amphibians, seedlings, and insects that depend on consistent humidity. In coniferous forests, vast moss mats can alter local microclimates, keeping temperatures cooler and preventing the air from drying out too quickly. Their presence helps shape the forest's daily rhythm: morning air thick with dew, afternoons softened by evaporative cooling, evenings filled with moist, earthy scents. This gentle humidity also reduces evaporation from soil, setting the stage for the final role in this sequence: how mosses slow water movement to protect the land beneath them. How mosses slow water runoff and protect soil highlights their silent engineering within the forest. When rain falls, moss cushions absorb the impact of each drop, preventing soil erosion and surface disturbance. Their dense mats act like natural sponges, soaking up water and releasing it steadily over time. By slowing runoff, mosses reduce the loss of nutrients from the soil and help replenish groundwater. On slopes, they stabilize the terrain by binding loose particles with rhizoids and trapping sediments. In wetlands and peatlands, thick moss layers form the foundation for entire hydrological systems, regulating water flow during storms and droughts. This protective role allows forests to remain resilient despite fluctuating weather patterns. And with the landscape safeguarded, the calm story of bryophytes continues into the next chapter of gentle forest interactions. Calm photosynthesis under deep forest shade shows how bryophytes flourish where many plants cannot. Mosses and liverworts rely on low light levels, gathering scattered photons that filter through layers of leaves and branches. Their chloroplasts sit close to the cell surface, allowing them to capture even the faintest glow that reaches the forest floor. In these dim spaces, photosynthesis becomes slow and unhurried, matching the quiet rhythm of the understory. Instead of competing for height or sun, bryophytes thrive by staying close to moisture and shadows, turning soft beams of greenish light into life. This patient metabolism supports consistent growth, even in places touched only by dawn or dusk light. And as pigments respond to shifting brightness, a gentle adaptation unfolds that prepares us for the next moment of their luminous world. Moss pigments, adjusting softly to low light, demonstrate the sensitivity and flexibility of bryophyte tissues. When shadows deepen, pigments such as chlorophyll rearrange within cells to maximize light absorption. Some mosses deepen in color, taking on richer greens, while others develop subtle red or brown tones that protect them from rare bursts of bright sun. These shifts allow mosses to maintain photosynthesis without stress, filtering sunlight through layers of thin leaves. As clouds move overhead or forest canopies thicken with new growth, pigments reorganize again, returning to calmer tones. This quiet shading dance helps mosses remain stable even in unpredictable environments. And when pigments capture enough light, they illuminate the forest floor gently, contributing to the green glow rising from moist canyon walls. Green glow rising from moist canyon walls often comes from thick moss beds thriving in narrow, shaded gorges. These places receive minimal direct sunlight, yet they gather enough reflected and scattered light to support vigorous growth. Moisture flows across stone surfaces, feeding mosses that cling to vertical cliffs where roots would never reach. As water evaporates slowly, it amplifies the soft radiance of the moss, making canyon walls appear lit from within. The glow changes throughout the day, brightening after rain and deepening during cool evenings. Tiny droplets cling to leaf tips, bending light into small, shimmering halos. In these sheltered spaces, bryophytes turn rock into living green architecture. And amidst this soft illumination, liverwort thalli begin to shimmer beneath filtered sun. Liverwort thalli shimmering beneath filtered sun display a different kind of luminosity, smooth and reflective compared to the textured shine of moss. Their flat, lobed surfaces capture light like gentle mirrors, making even faint sunbeams look brighter. As the sun passes through branches overhead, shifting patches of light move across the thalli, revealing translucent areas where water gathers in thin layers. These glowing patches help the liverwort regulate photosynthesis, warming slightly under the sun before cooling again when clouds drift by. The quiet flash of reflected light attracts small insects and reveals the delicate structure of the plant. When viewed up close, the thallus appears almost glass-like, glowing softly at the edges. This shimmering clarity showcases the next phenomenon of bryophyte light, the way illumination scatters through translucent cells. Light scattering through soft, translucent cells makes bryophytes appear gentle and luminous, even in dim environments. Each leaf, or thallus, is only a few cells thick, allowing sunlight to pass into the tissue and diffuse outward in a soft glow. This scattering effect gives mosses their characteristic brightness, especially when wet. As water increases internal reflection, the light moves through cell walls like a faint underwater shimmer, revealing internal structures and highlighting veins, pigments, and stored moisture. Scattering also improves photosynthetic efficiency by spreading light evenly across chloroplasts. When the forest canopy shifts, or the wind moves branches overhead, shadows glide across moss cushions without disturbing their gentle radiance. This quiet interplay of light and tissue leads naturally into the next chapter of bryophyte life. where moisture and illumination shape their continued growth. How bryophytes flourish in dim, humid habitats reflects their deep evolutionary connection to moisture and shadow. Their thin leaves and exposed chloroplasts allow them to photosynthesize efficiently under low light, making shaded forests, ravines, and canyon floors ideal places for growth. High humidity prevents them from drying out and supports essential processes such as nutrient absorption and reproduction. In these quiet environments, droplets cling to cell surfaces, creating thin films that mosses depend on. Humidity also softens the air around them, slowing evaporation and allowing bryophytes to maintain gentle hydration even during warm days. These dim places become cool sanctuaries where moss colonies spread across roots, stones, and decaying wood. As the forest light shifts, the dimness transforms into soft patterns of brightness and darkness, carried by the slow movement of sunbeams drifting across mossy logs. Sunbeams drifting across mossy logs create small, glowing pathways of warmth that travel slowly through the forest understory. As sunlight filters through layered branches, it breaks into long, gentle beams that slide across textured bark and vibrant green cushions. Moss absorbs this soft light without stress, taking advantage of short moments of brightness to support photosynthesis. These drifting rays highlight the tiny world of sporophytes, standing upright like miniature lanterns. When a cloud passes, the warmth fades, leaving behind a cool, emerald calm. Sunbeams reveal the structure of moss colonies, casting delicate shadows that shift lightly with the breeze. These moving patterns guide the eye toward subtler forms of light-shadow mosaics cast by leafy moss structures. Shadow mosaics cast by leafy moss structures appear whenever sunlight interacts with the layered forms of bryophytes. Each tiny leaf creates a soft-edged silhouette, contributing to an intricate network of overlapping shapes that dance across stones and soil. These shadows are never harsh. They blur at the edges, blending light and darkness into gentle gradients. Such patterns help regulate the temperature within moss cushions by cooling the spaces beneath them, creating microclimates where insects and microorganisms can thrive. As the sun shifts overhead, the mosaics change, revealing new textures and structures within the moss. This interplay of shadow and light highlights the calm efficiency of photosynthesis occurring beneath the surface, especially during the long mountain mornings when bryophytes perform some of their quietest work. Photosynthetic calm during long mountain mornings reflects the steady rhythm bryophytes follow in high-altitude forests. Morning light arrives slowly, softened by mist and chilled air drifting through valleys. Mosses use these extended hours of cool brightness to capture energy without risking dehydration. Their cells remain moist from overnight condensation, allowing chloroplasts to operate at full efficiency. The metabolism of bryophytes is unhurried, matching the tranquil pace of mountain dawns. Sporophytes glisten with dew, and liverwort thalli shine like tiny, polished stones. As sunlight intensifies, mosses shift their pigments to protect against stronger rays, maintaining balance throughout the morning. These peaceful routines guide bryophytes toward the habitats they prefer most strongly: the cool, shaded edges of streams. Why mosses prefer cool, shaded stream edges can be traced to their need for constant moisture, gentle temperatures, and subdued light. Streamside environments provide all three in abundance. Water vapor rises from flowing currents, increasing humidity and reducing the rate of evaporation from moss tissues. Shaded banks block harsh sunlight, protecting delicate cells from overheating. Moss clings to rocks, roots, and soil where the air remains cool even in midday. These environments also offer regular moisture from splashing water and seasonal flooding, allowing bryophytes to stay hydrated without relying on rain. Stream edges support some of the most vibrant and diverse moss communities, with species layering over one another in soft green terraces. And from these quiet banks, the next chapter of their story continues with interactions between bryophytes and the many organisms that share their shaded world. Moss cushions forming soft, pillowy landscapes turn the forest floor into a miniature world of quiet green architecture. Each cushion is made of countless tiny stems growing tightly together, their overlapping leaves creating spongy surfaces that hold water and soften the ground below. These cushions can rise like low hills on fallen logs, or spread into wide carpets along shaded soil. Inside them, moisture lingers long after rain has passed, sustaining microbes, springtails, and delicate larvae. When touched, the cushions compress slightly before springing back, showing their remarkable resilience. Their rounded shapes help them shed excess water and protect the stems within. As light shifts, the surfaces sparkle with beads of dew that reflect the surrounding forest in miniature. And from these calm, pillowy landscapes emerge the subtle vertical elements of moss-life sporophytes rising on slender setae. Sporophytes, rising on slender setae, stand like tiny towers above the soft green beds of moss. Each seta lifts a capsule high enough to release spores into gentle breezes. A simple structure shaped by millions of years of adaptation. These stalks vary in color, from pale yellow to deep red-brown, adding quiet accents to the moss cushions below. Their height allows spores to catch moving air rather than fall straight to the ground, increasing the chance of colonizing new surfaces. In morning light, droplets cling to the thin setae, highlighting their graceful curves. Despite their delicate appearance, these structures endure wind, rain, and passing animals. Rising just above the leafy gametophytes, sporophytes represent the next stage in the bryophyte life cycle, preparing for the moment when capsules release millions of drifting spores. Capsules releasing millions of drifting spores create one of the most subtle yet widespread reproductive events in the forest. Each capsule contains a densely packed mass of spores, so small that a single gust of wind can lift them into the air like invisible dust. When the capsule dries and opens, its structure guides the release, sometimes through tiny teeth-like openings that regulate the flow. Spores float on air currents, travel through gaps in the canopy, and settle in crevices on bark, rock, or soil. Some may land just centimeters away, while others can disperse for kilometers. This gentle scattering allows mosses to colonize new surfaces rapidly after disturbance. The airborne journey of spores leads to the creation of tiny forests on single roots or stones where new moss communities begin to grow. Tiny forests on single roots or stones form when spores find small but suitable habitats to colonize. Even the smallest stable surface, an exposed root, a rough pebble, or a fragment of old wood can support an entire micro-ecosystem of moss. As the first stems appear, they anchor themselves with rhizoids and begin to spread outward in soft green rings. These miniature forests trap moisture, filter light, and create pockets of cool air. Insects wander through their tiny branches as if exploring a full-sized woodland. Droplets gather between the stems, turning each small space into a sparkling valley. Over time, these microhabitats expand into patches large enough to support sporophytes, continuing the moss life cycle. And when viewed closely, even a single leaf of moss reveals enough structure to become an entire world of its own. Moss leaves, magnified into entire worlds, show the intricate beauty hidden within bryophytes. Under a hand lens, each leaf transforms from a simple green sliver into a landscape of veins, cells, and translucent edges. Some leaves are single-layered, allowing light to pass through like thin, stained glass. Others have tiny ridges or teeth that guide water across their surfaces. The cells themselves may be rounded, square, or elongated, and their arrangement determines how the leaf captures and holds moisture. Pigments appear richer when magnified, shifting from emerald to gold or deep olive depending on angle and light. These microscopic structures support photosynthesis, water absorption, and protection, all within a space smaller than a fingernail. By exploring these tiny architectures, we see how mosses build entire worlds from delicate components, guiding us toward the next chapter of their subtle forest life. Liverwort mats glowing like green lacquer reveal the unique luster of these ancient plants. Their flat, glossy thalli reflect light differently from moss leaves, creating a smooth sheen that looks almost polished. When moisture settles on their surfaces, the shine deepens, forming delicate highlights that shimmer beneath filtered sun. These liverwort mats often cling tightly to soil, bark, or stone, forming cohesive sheets of green that hug the forest floor. Their thin tissues absorb water quickly, making them responsive to even the softest rainfall or mist. In this hydrated state, they glow with a richness that transforms shaded areas into subtle mosaics of reflective green. Within these mats live tiny organisms, rotifers, nematodes, and fungi that thrive in the consistent moisture liverworts maintain. And among these radiant surfaces, another visual wonder emerges: the oversized, gleaming leaves of heucheria, one of the forest's most striking mosses. Heucheria leaves, shining with oversized cells, create a translucent beauty rarely seen in other moss species. The cells of Heucheria lucens are unusually large, giving each leaf a glass-like appearance when viewed up close. In shaded, humid forests, these leaves glow as light filters through them, revealing intricate internal structures. Their thin, delicate texture allows them to capture even faint illumination, making them appear almost luminous after rainfall. Heucheria often grows in mountain forests, where humidity is consistent and shade is deep, allowing its leaves to maintain their signature sheen. These glowing patches of moss draw attention even from afar, standing out against darker bark and decaying wood. And where Heucheria thrives, epixilic species often share the same damp, decomposing habitats, spreading across dead fir logs in quiet succession. Epixilic species spreading across dead fir logs show how bryophytes flourish on wood long after the tree has fallen. Dead logs retain moisture, provide rich organic material, and create shaded, cool environments, perfect conditions for mosses and liverworts. As epixilic species colonize the surface, they form layered communities that gradually break down the wood beneath them. Their rhizoids anchor into crevices, holding moisture and trapping nutrients that support fungi and insects, also living in the log. Over time, entire moss carpets develop, softening the sharp edges of the fallen tree. These green coverings become miniature ecosystems, home to springtails, beetle larvae, and microbes that thrive in humid darkness. And from among these thriving bryophyte communities rises one of the most impressive mosses in the forest: the common haircap, towering like miniature trees. Common haircap towering like miniature trees demonstrates how tall and structurally complex some moss species can become. Polytrichum commune grows in dense stands, with erect stems that can reach impressive heights, sometimes up to half a meter under ideal conditions. Each stem is covered in narrow, spiraled leaves that shimmer when wet. These moss trees form soft, waving fields that resemble tiny conifer forests when viewed from above. Their height helps them capture more light in shaded habitats and provides space for sporophytes to rise even higher. The dense stands also stabilize soil and retain moisture, supporting rich communities of microorganisms and invertebrates. Walking through a patch of common haircap feels like entering a scaled-down version of the surrounding forest. Yet even within this miniature forest, the bryophyte world reveals smaller wonders still, such as the brown shield moss, whose sporophytes mature quietly through winter. Brown shield moss sporophytes maturing through winter highlight the resilience and unusual timing of this rare species. Buxbaumia species are tiny and often overlooked because their gametophytes are nearly invisible, reduced to small patches hidden in soil or debris. The sporophytes, however, rise on delicate setae and carry flattened capsules that stand out against the forest floor. These capsules develop in late autumn and continue maturing through winter, surviving frost, snow, and freezing temperatures. By early spring, they open to release spores, just as moisture returns. This winter endurance allows brown shield moss to reproduce when competition is low and conditions are moistest. The life cycle of this moss is intimately tied to seasonal rhythms, reminding us how bryophytes synchronize themselves with the quietest parts of the forest year. And from here, the story moves naturally into even more hidden and ancient adaptations of these remarkable plants. Gemma cups scattering new liverwort plants reveal one of the quietest forms of asexual reproduction in the forest. These tiny, cup-shaped structures sit on the surface of the liverwort thallus, each containing delicate gemmae, small discs of tissue capable of growing into entire new plants. When raindrops fall into the cups, they create gentle splashes that send gemmae outward in small arcs. The droplets act like miniature catapults, carrying the gemmae to nearby bark, soil, or moss cushions where they can settle and begin to grow. This rain-powered dispersal allows liverworts to spread in calm, steady increments without relying on spores or fertilization. The gemmae land softly and anchor themselves in moist microhabitats, forming patches that slowly merge into wider green mats. And as these new plants take root, they demonstrate the broader power of vegetative fragments colonizing new forest spaces. Vegetative fragments colonizing new forest spaces show how bryophytes thrive through simple but highly effective regeneration. When pieces of moss or liverwort break off, whether from wind, footsteps, animals, or drying, they often continue growing wherever they land. Because each fragment carries cells capable of photosynthesis and water absorption, even a tiny portion can form the foundation of a new colony. These fragments lodge themselves in cracks of bark, sheltered soil, or the textures of decaying logs. Moisture triggers their revival, allowing rhizoids to anchor and new stems to develop. This ability helps bryophytes recover quickly from disturbance and spread across unstable or newly formed surfaces. As these fragments settle, the forest floor fills with subtle networks of green. When rain arrives, these growing colonies participate in another essential process: water guiding sperm cells across leaf surfaces. Water guiding sperm cells across leaf surfaces showcases the ancient dependence of bryophytes on moisture for reproduction. Male gametes are flagellated, meaning they swim using tiny whip-like structures. They require a thin film of water formed by dew, mist, or rainfall to move from male to female reproductive organs. This delicate journey happens on the surfaces of leaves, thalli, and moss cushions, where droplets connect structures into continuous pathways. As sperm cells travel, the forest becomes a microscopic landscape of shimmering channels illuminated by soft light. This reliance on water ties bryophyte reproduction to the quietest, most humid moments in the forest. When fertilization succeeds, a sporophyte begins to grow directly from the gametophyte, eventually rising on a seta that lifts its capsule above dense moss mats. Setae lifting capsules above dense moss mats illustrate the elegant engineering of bryophyte reproduction. The setae acts like a thin stem, elevating the capsule into the moving air so spores can disperse farther. This height advantage increases the likelihood that spores will reach new habitats rather than falling back into the parent colony. Setae grow from the fertilized egg and draw nutrients entirely from the gametophyte below. Their colors range from pale green to deep red, glowing softly when backlit by forest light. Droplets cling to their surfaces after rain, bending into sparkling beads that magnify the surrounding green. The raised capsule prepares to release spores into gentle breezes. But the sporophyte itself cannot live alone, leading us to its final dependency. Sporophytes, relying entirely on gametophytes. Sporophytes, depending entirely on gametophytes, highlights the deep interconnection at the heart of bryophyte life cycles. Unlike vascular plants whose sporophytes become independent, bryophyte sporophytes remain attached to and nourished by the gametophyte throughout their lives. The gametophyte supplies water, minerals, and carbohydrates through a simple transfer tissue at their point of connection. This dependence means sporophytes grow only where conditions are moist and stable enough for the gametophyte to thrive. The arrangement ensures that developing capsules are always anchored in healthy, hydrated colonies. As the sporophyte matures, the gametophyte continues photosynthesizing quietly beneath it, supporting its upward growth until spores are ready to disperse. This intimate relationship marks one of the oldest plant strategies on Earth and guides us toward the next chapter of their slow, rhythmic forest cycles. Dioecious species forming male and female turf patches create gentle patterns across the forest floor. In these bryophytes, individual plants produce only male or only female reproductive organs, resulting in small colonies that differ subtly in color, texture, or height. Male patches often appear slightly brighter or more compact, while female patches may grow taller as they prepare to support sporophytes. Rainfall or mist connects these separate clusters through thin water films that allow sperm cells to travel between them. Over time, male and female turfs form mosaics shaped by moisture, shade, and chance dispersal. These distinct patches also influence the microfauna that live among them, offering varying structures for insects and microorganisms. Each patch reflects a different phase of the life cycle, setting the stage for the quiet longevity of moss species that may live for months or decades. Moss species living months or decades demonstrate the incredible range of bryophyte lifespans. Some ephemeral mosses complete their entire cycle within a single season, thriving in temporarily wet habitats like streambanks or forest edges. Others, such as common haircap or peat mosses, can persist for many decades, forming dense, layered mats that grow slowly over time. These long-lived species accumulate organic matter beneath them, gradually creating soil rich with moisture and nutrients. Their longevity depends on stable humidity, consistent shade, and slow, steady hydration. Whether fleeting or ancient, each moss colony follows a rhythm tied to environmental cues. And one of the strongest cues arrives after sunset, when nighttime humidity begins to rise and trigger new growth across the forest. Nighttime humidity triggering new growth showcases the intimate link between bryophytes and the soft rise of moisture after dusk. As temperatures fall, water vapor condenses on moss surfaces, collecting in delicate beads that hydrate cells for hours before sunrise. This gentle moisture allows mosses to photosynthesize at dawn when light is faint but conditions are cool and saturated. The increased humidity also signals spores to germinate, rhizoids to anchor, and new stems to expand. During the night, forest air becomes a quiet reservoir of moisture, filling shaded hollows and pooling along low ground. This nocturnal hydration sets the foundation for seasonal changes, especially as spring warmth arrives to ripen tiny spores. Spring warmth ripening tiny spores brings a slow but meaningful shift in the bryophyte world. As temperatures rise and daylight lengthens, sporophyte capsules begin to mature, their outer walls drying and preparing for release. Inside each capsule, microscopic spores divide, specialize, and compact themselves into structures capable of long-distance travel. The warming air gently accelerates this ripening, causing color changes that signal readiness. When conditions are perfect, slightly warm, lightly breezy, and dry, the capsules open, releasing spores into the forest canopy. These drifting specks begin the next generation of moss, landing on moist soil, bark, or stone. And while spring stirs the forest awake, mosses continue, enduring harsh winters in silence, waiting for this subtle return of warmth. Mosses enduring harsh winters in silence demonstrate their extraordinary resilience in cold seasons. As temperatures drop, mosses lose water and enter a dormant state, their leaves curling tightly to protect delicate cells. Covered by frost, snow, or ice, they appear lifeless, yet their tissues remain intact, protected by antifreeze-like compounds that prevent cellular damage. Under snowbanks, mosses experience surprisingly stable temperatures, insulated from extreme cold by the snow itself. Winter winds pass overhead, while the moss rests quietly beneath, waiting for the slightest hint of thaw. When sunlight finally warms the surface and ice melts into gentle droplets, mosses rapidly rehydrate, their leaves unfurling in moments. This silent endurance ensures they are among the first plants to revive in early spring, ready to continue their ancient cycles of growth. Mosses, reclaiming old-growth forest logs, demonstrate how bryophytes quietly weave themselves into the afterlife of trees. As fallen trunks slowly absorb rain and soften over time, mosses become some of the first plants to colonize the decaying wood. Their rhizoids thread into crevices, stabilizing loose bark and trapping moisture that would otherwise evaporate. Over years, moss layers thicken, forming vibrant green blankets that protect fungi, insects, and microorganisms thriving beneath. These cushions regulate humidity and temperature within the log, helping decomposition proceed in slow, steady waves. As seasons change, frost glitters across the moss in winter, and summer rains deepen its color to luminous emerald. The entire log becomes a living platform for new growth, its surface transformed from coarse wood to a soft, thriving microforest. And among these reclaimed habitats, epixilic species appear subtle indicators of true forest naturalness. Epixilic species revealing forest naturalness serve as quiet biological markers of ecological continuity. These mosses and liverworts specialize in growing on decaying wood rather than soil or stone, meaning they depend on forests rich in long-standing dead wood. Their presence suggests a habitat undisturbed for decades or centuries, where fallen trees decompose slowly under shade and moisture. Species such as heucheria, green shield moss, and others thrive only where humidity remains stable and logs decay in gradual cycles. Their delicate structures absorb water directly from mist and rainfall, becoming vivid and translucent after storms. Because they rely on specific microhabitats, their occurrence indicates a forest operating close to its natural rhythms. These subtle epixilic patches often appear near the bases of living trunks as well, guiding us toward the next soft pattern in moss ecology: the halo-like rings forming at tree bases. Moss halos forming at tree bases emerge where moisture, shade, and stable soil conditions meet. These circular or semicircular patches spread outward around trunks, fed by water dripping from leaves and rain channeled down bark. The halo's inner edge stays sheltered and humid, creating ideal conditions for mosses to anchor and expand. Small stones, twigs, and leaf litter captured within the ring help retain additional moisture, turning the base of the tree into a cool microclimate. Over time, the halo thickens into a velvety band that softens the transition between soil and bark. In older forests, these rings may glow with rich greens or muted golds, depending on species and season. And on certain tree types, especially maples, epiphytic mosses thrive even higher up the trunk, forming quiet gardens on the bark above. Epiphytic mosses thriving on maple bark reveal how bryophytes inhabit vertical worlds within the forest. Maple bark provides a slightly textured, moderately acidic surface ideal for moss attachment. Its ability to retain moisture after rainfall creates small humid pockets where moss can flourish even several meters above the ground. Epiphytic species spread across the bark in thin films or dense tufts, capturing mist, dew, and rain before it reaches the soil. These mosses help moderate bark temperature, sheltering insects and tiny invertebrates within their soft layers. When sunlight filters through leaves, patches of green glow faintly across the trunk, highlighting the delicate patterns of overlapping stems. As these vertical gardens grow, they soften the appearance of the tree and create new habitats. And when moss climbs higher still, it transitions into epilithic mats, softening the exposed rock faces nearby. Epilithic mats, softening rock faces, show how mosses transform even the hardest surfaces into gentle, living textures. Rock absorbs heat quickly and loses moisture fast. Yet certain moss species evolve to cling to its rough edges, cracks, and shaded ledges. These mats catch rainfall and dew, holding moisture long enough to support photosynthesis in thin, exposed places. Over time, moss softens the harsh geometry of stone, turning cliffs, boulders, and canyon walls into velvety patches of green. These mats trap dust and organic fragments, gradually creating thin layers of primitive soil where lichens, liverworts, and tiny seedlings take root. Their presence cools the rock surface, reducing heat stress during warm days. Epilithic mosses often glow brightest after rain, their wet leaves shining like jade. From these softened rock faces, the story deepens into even more hidden, sheltered places where bryophytes quietly thrive. Moss beds, sheltering endangered forest species, show how these soft green carpets serve as refuges for organisms that cannot survive in harsher environments. Within their dense layers, humidity remains stable, temperatures fluctuate gently, and predators have difficulty navigating the tight spaces. Many rare insects, tiny snails, and microfauna rely on moss beds as their only safe habitat. Amphibians rest beneath the cushions to avoid drying out, and seedlings germinate in the moist soil protected by moss. These beds also host rare epixilic species that depend on decaying wood untouched by disturbance. In old-growth forests, the presence of extensive moss beds often correlates with high biodiversity, especially among organisms sensitive to drought or soil loss. As the beds spread through shaded hollows and across fallen logs, they create a soft network of protection. And these networks become even richer in the deep valleys and wet ravines where entire bryophyte communities gather. Communities forming in deep valleys and wet ravines demonstrate how moisture and shade shape bryophyte diversity. These sheltered landscapes collect cool air and flowing water, creating ideal microclimates for mosses and liverworts to thrive. Fog drifts along the valley floor, condensing on stones and bark where bryophytes quickly absorb it. The reduced sunlight and constant humidity support species that cannot tolerate drier or brighter habitats. Many rare mosses, especially transparent, delicate types like hookeria, form vivid patches along ravine walls. Liverworts spread across roots and damp soil, forming lace-like mats that glow beneath filtered light. These ravines serve as natural reservoirs of bryophyte diversity, harboring species that might vanish from surrounding uplands. Water trickling down stone surfaces leads us toward another specialized habitat, the carbonate springs and dripping rock, where certain species cling with remarkable persistence. Species clinging to carbonate springs and dripping stone display extraordinary adaptations to mineral-rich environments. In these places, water saturated with calcium carbonate flows steadily over wood and rock, leaving behind chalky deposits. Mosses and liverworts that inhabit these springs tolerate constant moisture and fluctuating mineral loads. Their leaves trap droplets, forming glistening layers that reflect the surrounding forest like mirrors. Some species grow directly in the thin films of flowing water, anchoring themselves to submerged bark or rough stone. Over time, carbonate precipitation forms crusts around the plants, encasing leaves and stems in pale deposits. Yet many bryophytes persist, continuing to photosynthesize beneath or between these crystalline layers. This mineral burden creates a quiet struggle that becomes even more striking when liverworts begin battling calcareous deposits that threaten to bury them. Liverworts battling calcareous deposits reveal the delicate resilience of these ancient plants. At carbonate springs, precipitation from mineral-rich water gradually builds white crusts over everything it touches. Liverwort thalli, normally smooth and flexible, become partially coated in hard layers that restrict their growth. Yet many species push through, producing new tissue at the thallus edges and slowly lifting the crusts as fresh lobes expand. Some species, like greasewort, grow so close to the substrate that the calcareous deposits form intricate patterns around them, making each thallus appear framed by pale stone. These liverworts use constant moisture to stay active despite the mineral load, photosynthesizing beneath thin films of water. Their ability to persist in such challenging conditions leads us to another unexpected habitat: man-made structures, where bryophytes show the same adaptability. Bryophytes thriving in man-made habitats like concrete demonstrate how these tiny plants succeed even in environments shaped by human activity. Concrete surfaces retain moisture after rainfall and provide stable, rough textures ideal for moss and liverwort attachment. Despite the alkaline nature of concrete, many species tolerate or even prefer these conditions, colonizing walls, bridge supports, pavements, and abandoned structures. Mosses trap dust and organic particles, gradually creating thin layers of soil that support expanding colonies. In cities, bryophytes soften the harsh lines of buildings, adding patches of green to aging stone and concrete blocks. Their resilience allows them to survive in polluted air, fluctuating temperatures, and intermittent water supply. These urban bryophyte communities echo the same quiet strength found in wild habitats, connecting human landscapes to the ancient, enduring cycles of forest life. Bryophytes sheltering salamanders and insects show how mosses act as quiet guardians of forest life. Their dense mats hold cool moisture even on warm days, creating microclimates that amphibians depend on to prevent dehydration. Salamanders slip beneath moss cushions where humidity stays high, allowing their delicate skin to breathe. Insects hide within the layered leaves, navigating a miniature world of tunnels and chambers that shield them from predators and wind. Moss beds provide a stable temperature, absorbing heat during the day and releasing it slowly at night. Beneath these soft shelters, tiny roots of seedlings begin to grow. Fungi weave delicate threads, and countless microorganisms thrive. The safety offered by bryophytes extends upward as well, shaping the habits of many forest animals. Birds, for example, often gather these soft green materials to line nests with gentle, insulating cushions. Birds lining nests with soft moss cushions reveal the way bryophytes support larger forest creatures with their delicate textures. Moss provides insulation against cold weather, retaining warmth around eggs and nestlings while controlling humidity inside the nest. Its natural ability to absorb and release moisture slowly prevents dampness from building up. Birds search for the freshest, most pliable moss patches, gently plucking tufts to weave into their nests. These green linings soften the interior, cushion fragile eggs, and camouflage nests among surrounding foliage. The moss used in nests often continues living, slowly growing as humidity rises with the bird's breath. This quiet partnership connects bryophytes to the life cycles of many species. Within the moss-lined crevices of the forest floor, another tiny resident thrives, springtails living in moss microcanyons. Springtails living in moss microcanyons inhabit one of the smallest landscapes imaginable. These tiny arthropods explore gaps between moss leaves that resemble narrow valleys, ridges, and plateaus when seen up close. The humid air trapped within these spaces protects springtails from drying out, while the abundant decaying organic matter provides a steady food source. Springtails help moss communities by breaking down detritus, cycling nutrients, and dispersing fungal spores. Their movements appear like gentle pulses across the moss surface, responding instantly to changes in humidity. In rain, they shelter deeper within the moss, and under soft sunlight, they emerge to feed. Their presence maintains the health of moss mats and supports the broader ecosystem. As these microcanyons teem with life, another quiet traveler moves through them, snails gliding silently through moss moisture. Snails gliding silently through moss moisture illustrate how bryophytes create ideal pathways for slow-moving creatures. Moss retains water along its leaves and stems, forming a soft, hydrated surface, perfect for snails to travel across without drying out. These moist corridors allow snails to reach decaying wood, fungi, and young shoots that make up their diet. As they glide, their movements leave subtle trails that glisten in morning light. The cool, stable microclimate beneath moss cushions protects snails from harsh temperatures and predators. Their grazing helps regulate algae and fungal growth within moss communities, contributing to ecological balance. Snails also disperse tiny plant fragments and spores, helping bryophytes colonize new spaces. As they glide through these green carpets, the moss itself performs another essential service, filtering pollutants from rainwater before it reaches the soil. Moss filtering pollutants from rainwater demonstrates the quiet cleansing power of bryophyte layers. As rain drips through moss cushions, the overlapping leaves trap dust, sediments, and airborne particles that accumulate on the forest canopy. Moss surfaces bind certain pollutants, including heavy metals and organic compounds, preventing them from entering streams or soil. Their slow absorption and release of water act as a natural filtration system, improving water quality within forest ecosystems. In areas near human activity, mosses even serve as bioindicators, reflecting the presence of pollutants in the air. The filtered water that emerges beneath moss mats is clearer and cleaner, nourishing roots and microorganisms in the soil below. Through this gentle purification process, bryophytes protect the forest's hydrological balance and prepare us for the next chapter of their quiet companionship with the land. Pioneer bryophytes preparing soil for new plants show how mosses and liverworts quietly begin the first chapters of ecological succession. When they settle on bare rock, sand, or decaying wood, they trap dust, moisture, and organic particles that gradually accumulate into thin layers of primitive soil. Their slow growth and gentle decay add carbon and nutrients to these early substrates. Over time, the cushions loosen the surface beneath them, allowing bacteria, fungi, and tiny invertebrates to move in and accelerate soil formation. As bryophytes hold moisture, they soften temperature swings, creating a microclimate where the earliest seedlings can survive. Once vascular plants arrive, the moss foundation stabilizes their roots and protects young shoots from drying winds. These quiet pioneers shape the forest long before trees return. And in the shelter of these soft green beds, small mammals sometimes hide food in moss layers. Small mammals hiding food in moss layers reveal how bryophytes offer storage, camouflage, and protection within their dense textures. Species like voles and shrews tuck seeds, nuts, and fungi into moss mats where moisture and cool temperatures slow decay. The layered leaves conceal small caches from predators and competitors, creating natural storage vaults scattered across the forest floor. As these animals forage through moss, they disturb the surface, spreading spores and plant fragments that help bryophytes colonize new areas. Their hidden stores sometimes sprout into seedlings, using the moss as a nursery bed. Moss cushions insulate these tiny hordes through frost and rain, keeping them dry enough to preserve. Yet even as bryophytes assist mammals, they must also coexist with larger plants nearby, gently competing without overwhelming the forest floor. Moss competing gently with vascular plants highlights a quiet balance rather than aggressive rivalry. Mosses spread across soil surfaces, shading them lightly and reducing evaporation. This helps some seedlings establish but prevents others from rooting if the moss layer becomes too thick. Because bryophytes absorb water passively and require moisture, they rarely dominate sunlit or dry areas where vascular plants thrive. Instead, they fill the shaded, humid gaps that larger plants overlook. Their slow growth and shallow anchoring allow roots of shrubs and trees to pass through easily. Moss cushions protect soil from erosion and temperature swings, indirectly supporting vascular plant health. This gentle coexistence sets the stage for mixed communities in which lichens and moss form quiet mosaics across bark and stone. Lichens and moss forming quiet mosaics demonstrate the harmony between two ancient groups of organisms. Lichens, composed of fungi and algae, favor exposed, nutrient-poor surfaces, while mosses prefer shaded, moister niches. Together, they create patchworks of color and texture, silvery crusts, green cushions, golden mats across rocks, logs, and tree trunks. These mosaics stabilize surfaces, trap organic matter, and support microfauna. Their arrangement often reflects subtle gradients of sunlight, humidity, and airflow. After rain, the entire mosaic comes alive in shifting hues, with lichens brightening and mosses deepening into rich green. The interactions between them form intricate borders where neither outcompetes the other completely. Within these tiny landscapes, even smaller pathways appear, including the winding routes of ants and mites navigating through moss forests. Ant and mite paths winding through moss forests reveal how bryophyte cushions act as miniature landscapes filled with hidden roots. Ants use moss as sheltered highways, moving beneath leaves and stems where predators are scarce and humidity is stable. Meaties inhabit even finer spaces, slipping between single-cell layers and feeding on fungi or decaying organic matter. These pathways support nutrient cycling and soil formation, as tiny creatures break down material that accumulates in the moss. Their movements aerate the underlying substrate, loosening soil particles and dispersing spores. Morning dew highlights these networks, glistening along ridges and valleys in the moss just as light touches a full-sized forest. And from these bustling micropathways, the next chapter of bryophyte ecology emerges in the hidden relationships shaped by climate, moisture, and ancient lineage. Peat moss shaping global carbon storage demonstrates how bryophytes influence Earth on a planetary scale. Species of sphagnum create vast carpets in cool, waterlogged landscapes where decomposition slows almost to a halt. Their tissues absorb water like sponges, and as each generation grows upward, older layers beneath them become compressed into peat. This peat locks away immense amounts of carbon, more than all the world's forests combined, helping regulate the climate over millennia. The moss itself releases compounds that acidify the water around it, further slowing decay and enhancing carbon preservation. These quiet wetlands act as the Earth's breathing spaces, absorbing carbon in cool seasons and holding it tightly during warm ones. Within these deep green expanses lies the memory of entire ecosystems, leading naturally into the peatlands, storing centuries of forest history. Peatlands, storing centuries of forest history, preserve ancient layers of plant material, pollen, spores, and traces of past climates. Each season adds a thin sheet of organic matter that sinks gradually into waterlogged depths. These layers form a timeline of environmental change, recording droughts, fires, species shifts, and atmospheric conditions. Scientists can extract cores from peatlands to read this slow archive, discovering what forests looked like thousands of years ago. The cool, oxygen-poor environment prevents decay, keeping even delicate bryophyte fragments intact. Moss stems remain recognizable, tiny leaves still curled in their original shapes. These preserved ecosystems remind us how stable and enduring bryophytes can be. At the same time, their layered structure slows the natural flow of water across landscapes, guiding us toward moss layers, slowing the movement of water. Moss layers slowing the movement of water provide essential hydrological balance in forests, wetlands, and mountain slopes. Their spongy structure absorbs rainfall instantly, holding moisture that would otherwise surge downhill. As the water spreads through overlapping leaves, it moves gradually downward, replenishing soil instead of rushing away. This gentle release prevents erosion, reduces flooding, and maintains steady hydration for surrounding vegetation. Moss cushions act like tiny reservoirs, storing water during storms and distributing it during dry periods. Their presence supports seedlings, fungi, and invertebrates that depend on reliable moisture. On steep terrain, these slow-flowing mats are especially important, protecting thin soils from being washed away. Their stabilizing influence becomes even more critical in high-altitude environments, where bryophytes also help anchor fragile mountain landscapes. Bryophytes, stabilizing fragile mountain soils, is one of their most important ecological roles. In alpine and subalpine regions, thin soils cling to rocky surfaces and steep slopes, vulnerable to wind, frost, and sudden rain. Mosses and liverworts form dense mats that weave across these surfaces, their rhizoids gripping particles of soil and sand. These mats reduce erosion by holding moisture, buffering temperature changes, and supporting early colonizing plants. Their presence allows grasses, herbs, and dwarf shrubs to root more easily, gradually building stronger plant communities. In winter, snow settles gently on moss beds, insulating the soil beneath from extreme cold. When spring arrives, meltwater seeps slowly through these bryophyte layers instead of flowing away. Because their growth responds closely to environmental change, these mountain mosses also serve as subtle climate recorders, guiding us toward the idea of moss acting as a sensitive climate indicator. Moss acting as a sensitive climate indicator reveals how these tiny plants respond quickly to shifts in temperature, moisture, and air quality. Bryophytes absorb water and nutrients directly from the air and rainfall, making them vulnerable to pollution and drought. Changes in species distribution, such as mosses retreating from drying habitats or appearing in newly humid areas, offer early signs of climate shifts. Some species vanish when temperatures rise just a few degrees, while others expand as rainfall increases. Researchers study moss pigments, growth patterns, and accumulated pollutants to understand long-term environmental trends. Even small changes in canopy cover or fog frequency can reshape moss communities within a season. Their quiet sensitivity allows forests to signal subtle transformations long before larger plants begin to show stress. And through this silent record-keeping, bryophytes continue linking ancient memory to the living climate around them. Cold-adapted species thriving near alpine streams reveal how bryophytes flourish where few plants can survive. These mosses grow beside icy water that tumbles down mountain slopes, receiving constant mist and chilled humidity. Their cells function efficiently at low temperatures, and many species maintain photosynthesis even when the air feels crisp enough to bite. The moss cushions along these stream edges anchor themselves to rocks with fine rhizoids, gripping firmly despite the rushing water. Droplets cling to their leaves in clear beads, reflecting the sky like tiny lenses. Even in early spring, when snowmelt floods the valleys, these mosses stay vibrant, using the cool moisture to expand their soft carpets. Their quiet persistence in extreme cold mirrors another survival story unfolding farther north, where Arctic mosses remain active beneath the winter snow cover. Arctic mosses surviving under snow cover show how bryophytes endure some of the coldest environments on Earth. Snow, rather than harming them, acts as insulation, trapping pockets of air that keep temperatures more stable beneath the surface. Under this soft white blanket, mosses remain hydrated, protected from freezing winds that sweep across the tundra. Many Arctic species photosynthesize at just above freezing, allowing them to grow slowly during the dim polar summer. Their leaves often contain antifreeze-like compounds that prevent cellular ice damage, and their compact growth forms resist moisture loss. When the snow retreats, these mosses emerge green and ready, absorbing meltwater instantly. Their resilience in a frozen world echoes the same quiet determination shown by desert moss, which awakens after even the briefest rain. Desert moss awakening after brief rain reveals a form of survival that feels almost miraculous. In arid landscapes where moisture may not arrive for months, mosses remain curled and dormant, appearing lifeless on sand or stone. But the first raindrop triggers rapid transformation. Leaves unfurl, tissues swell, and photosynthesis resumes within minutes. Some species complete their reproductive cycle in a single wet day, releasing spores before the ground dries again. Their poikilohydric bodies allow them to tolerate extreme dehydration without damage, making them some of the toughest bryophytes on Earth. After rain, desert moss glows deep green against the normally muted soil, forming small islands of color across barren terrain. Their presence in such harsh environments mirrors the ancient stability found in old-growth moss communities, marking forests untouched for centuries. Old-growth moss communities marking ancient forests act as living signatures of ecological continuity. These communities contain species that require decades of stable humidity, shade, and undisturbed substrates to form dense, multi-layered carpets. Many appear only in forests where dead wood accumulates naturally and where human activity has remained minimal. Their structure includes thick blankets on logs, delicate epiphytes on aging trunks, and rare species that cling to long-standing ravines or mountain shadows. These mosses host diverse microfauna, forming ecosystems that reflect centuries of forest development. Scientists use them as indicators of habitat quality and forest age. Yet even these resilient communities are vulnerable as landscapes change, leading us toward the quiet but troubling reality of threatened bryophyte species disappearing with habitat loss. Threatened bryophyte species disappearing with habitat loss highlights the fragility of these ancient plants. Many mosses and liverworts depend on very specific microhabitats, cool ravines, dripping springs, decaying logs, or undisturbed forest floors. As forests are logged, drained, fragmented, or dried by climate change, these habitats vanish. Light increases, humidity drops, and delicate species fade from their former ranges. Because bryophytes absorb water and nutrients directly from the air, they are highly sensitive to pollution and drought. Some species now survive only in isolated pockets, where conditions remain stable. Their disappearance signals deeper ecological imbalance, affecting moisture cycles, soil formation, and microfaunal communities. The loss of bryophytes represents the quiet unraveling of ancient forest systems, yet their persistence elsewhere reminds us of the resilience waiting in the next chapter of their story. Night air condensing as silver films on moss creates one of the forest's most delicate nightly transformations. As temperatures fall after sunset, moisture in the air begins to settle onto cool surfaces. Moss cushions are among the first to gather these droplets. Thanks to their intricate leaf structures and large surface area, the thin films that form glisten faintly, turning each moss bed into a quiet, silver-coated landscape. These moisture layers hydrate the bryophytes long before dawnlight arrives, allowing them to begin photosynthesis immediately when the first rays reach the forest floor. This nightly condensation also regulates the temperature within moss mats, slowing heat loss and creating tiny thermal refuges for invertebrates. The gentle shimmer of these silver films catches even the softest moonlight, guiding us into the next subtle moment. Moonlight reflecting on damp bryophyte cushions. Moonlight reflecting on damp bryophyte cushions adds a serene luminosity to the forest's nighttime calm. When mosses are wet, their translucent cells scatter light softly, turning each cushion into a dim, glowing patch beneath the canopy. Moonbeams passing between branches strike the moist surfaces, creating halos and faint gleams that pulse with the movement of drifting clouds. This reflected light is gentle enough not to disturb animals of the night, but bright enough to reveal textures and shapes hidden during daylight. The damp cushions remain warm compared to surrounding air, maintaining stable moisture that supports nocturnal insects and microfauna. These glowing patches often appear like quiet constellations scattered across the forest floor. And as moonlight fades behind clouds, the glow shifts downward into the cool stones, darkening with mist. Cool stones darkening with mist show how nighttime moisture transforms even the hardest forest surfaces. As humidity rises, droplets gather on stone, slowly deepening its color to rich shades of charcoal and green. Mosses clinging to these stones amplify the effect, their leaves absorbing moisture and darkening even more rapidly. The temperature difference between stone and air creates microcurrents that draw fog into sheltered crevices. These darkened surfaces help maintain the cool microclimate that bryophytes depend on, while also offering safe passage to creatures like springtails, snails, and mites. By dawn, the mist-fed stones often glisten as though polished, radiating stored coolness into the returning light. And as these stones hold moisture, the moss growing upon them begins a slow, rhythmic nighttime cycle resembling breathing, leading us toward moss breathing softly in the darkness. Moss breathing softly in the darkness describes the subtle exchange of gases that continues even after the forest has fallen into stillness. Bryophytes absorb oxygen and release carbon dioxide at night, reversing their daytime pattern. This metabolic shift occurs quietly through tiny pores called stomata, or, in liverworts, through surface openings that never fully close. The moist nighttime air enhances these exchanges, keeping moss cells hydrated enough to remain active. As temperature drops, respiration slows, creating a gentle rhythm that blends with the ambient calm of the forest. Under a hand lens, one might see microdroplets forming along leaf edges, signaling that the moss is still alive and working. These quiet physiological processes deepen the sense of stillness, contributing to the forest's nocturnal atmosphere. And as moss breathes under the dark canopy, the entire woodland responds. The forest quiet, deepening around wet moss. Forest quiet deepening around wet moss reflects how moisture softens sound and slows movement throughout the night. When moss is saturated, it absorbs vibrations, muffling the footsteps of animals and the fall of branches. The forest floor becomes a soft, hushed expanse where even raindrops seem to land more gently. Humid air thickens acoustics, creating an enveloping stillness that feels almost physical. In this calm darkness, microfauna stir softly within moss layers, while larger animals move with deliberate, muted steps. The scent of wet earth intensifies, mixing with the cool freshness that rises from moss cushions. This deepened quiet signals that the forest is resting, its rhythms slowed and softened until dawn. Within this hush, the night prepares the bryophytes for the next phases of their quiet ecological cycles, continuing their ancient dance with moisture and time. Nocturnal insects moving through moss passages reveal a hidden world that awakens after sunset. As darkness settles over the forest, insects such as springtails, tiny beetles, and delicate moth larvae navigate the narrow spaces between moss leaves. These passages act like miniature tunnels that retain humidity, offering a safe pathway protected from predators and dry air. The moisture within these moss corridors keeps their bodies from dehydrating, while the soft terrain muffles their movements. Under moonlight, their tiny forms slip through valleys of green, brushing past sporophytes and droplets clinging to leaf tips. Their nighttime activity helps break down organic matter and disperse fungal spores, playing a vital part in nutrient cycling. As they weave through these micro-landscapes, they disturb droplets just enough to shift them into new positions, guiding the formation of dew between tiny leaf spirals. Dew forming between tiny leaf spirals shows how bryophytes gather nighttime moisture with delicate precision. As temperatures cool, airborne water condenses along the fine edges of moss leaves, collecting in spiraled arrangements that channel droplets deeper into the plant. These spirals create narrow pockets where dew accumulates, forming tiny beads that glimmer under faint starlight. The structure of each leaf, just 1 or 2 cells thick, helps draw moisture inward through capillary action. This gentle hydration allows moss to remain physiologically active through much of the night. The dew also supports microfauna that drink or absorb the droplets. In the early hours, these beads become reflective surfaces, catching glimpses of the night sky. Through these tiny mirrors, the first hints of the next poetic moment emerge. Stars mirrored in mossy water droplets. Stars mirrored in mossy water droplets offer one of the forest's smallest and most magical illusions. When dew or condensation settles on moss cushions, each droplet forms a curved lens capable of reflecting the night sky above. Under clear conditions, faint starlight becomes visible in these spherical beads, creating tiny galaxies scattered across the forest floor. This effect is strongest on smooth liverwort thalli or fully hydrated moss leaves, where surfaces shine like polished glass. The clarity of these reflections reveals how clean and pure the incoming moisture is, having been filtered gently through layers of air and forest canopy. As droplets shift with slight air movements or the passing of insects, the mirrored stars flicker softly. These luminous beads often linger until clouds gather or rain arrives, guiding us toward calm rain lingering until dawn. Calm rain lingering until dawn describes the slow, gentle precipitation that nourishes bryophytes through the night. Unlike heavy storms, these soft showers fall in fine droplets that accumulate evenly across moss cushions, stones, and leaves. The forest absorbs the sound, turning rainfall into a faint, rhythmic whisper. Mosses swell as they soak up the moisture, becoming brighter and more vibrant even before sunrise. The extended wetness allows spores to hydrate, sporophytes to stand more firmly, and gametophytes to continue metabolic activity for hours. Many nocturnal animals forage more confidently during such quiet rain, knowing predators are less likely to hear them. By dawn, the forest floor glows with renewed saturation, each moss cushion holding a reservoir of water that will sustain life throughout the day. As this gentle rain fades, moss life begins pulsing gently through night cycles. Moss life pulsing gently through night cycles reflects the rhythmic patterns bryophytes follow through darkness, moisture, and silence. Even without sunlight, mosses remain subtly active. They respire, exchange gases, expand hydrated tissues, and stabilize temperatures within their cushions. Tiny movements spore capsule shifts, leaf edges uncurling slightly. Microfauna stirring between stems create a nearly imperceptible pulse within the mats. Night moisture allows many metabolic processes to continue at low levels, preparing the moss for rapid photosynthesis as soon as dawn light returns. This gentle pulse influences other forest rhythms: humidity levels, scent dispersal, insect foraging, and even soil cooling. As night deepens, the moss ecosystem settles into a steady, quiet flow that mirrors the larger cycles of the forest. Through these calm night rhythms, bryophytes carry ancient patterns forward, closing the final chapter of their nocturnal world. Bryophytes surviving extreme climates across Earth reveal a resilience unmatched by most plant groups. From the icy tundra to the edges of deserts, these ancient plants endure conditions that would overwhelm more complex vegetation. Their simple tissues allow rapid hydration and equally rapid drying, letting them pause metabolism during unfavorable periods. In polar regions, they photosynthesize at temperatures near freezing. In tropical mountains, they cling to mist-soaked cliffs. In volcanic landscapes, they colonize fresh lava rock. Their global distribution shows how adaptable they are to shifts in humidity, temperature, and light. This tolerance for extremes supports insects, fungi, and small animals that rely on moss carpets for moisture or shelter. And when dryness reaches its peak, bryophytes retreat into protective states, preparing for the quiet transformation that defines the next extraordinary ability: moss reviving after total desiccation. Moss reviving after total desiccation showcases one of nature's most remarkable survival strategies. When conditions become too dry, mosses lose almost all internal water, their leaves curling inward until the plants appear brittle and lifeless. Yet, their cells remain intact, thanks to protective sugars and proteins that stabilize their structures. After days, months, or even years without moisture, a single drop of dew can trigger rapid rehydration. Leaves unfurl, chloroplasts reawaken, and photosynthesis resumes within minutes. This ability allows mosses to outlast droughts, wildfires, and seasonal extremes that wipe out other plant life. Their revival also reactivates the microhabitats surrounding them. Springtails stir, fungi spread through fresh moisture, and soil processes resume. In these resurrected carpets, other bryophytes flourish as well, including those that have existed for ages on the oldest forest floors, such as the resilient liverworts thriving under ancient canopies. Liverworts thriving on ancient forest floors reflect ecosystems that have remained undisturbed for centuries. These delicate plants prefer cool shade, constant humidity, and thick layers of decaying leaves or wood, all signs of long-term ecological stability. In such old-growth habitats, liverworts form intricate mats that cling to roots, stones, and fallen trunks. Their glossy thalli capture dew and fog, creating gentle reservoirs for surrounding microfauna. Some species reproduce slowly, relying on stable conditions to maintain their populations across decades. Their presence signals a forest that retains its original rhythms, with minimal disturbance from drought, logging, or fragmentation. Alongside mosses and lichens, liverworts act as a foundational layer of biodiversity. And among these ancient communities grows another small but extraordinary group of bryophytes, hornworts, whose sporophytes grow without the familiar setae seen in other mosses. Hornwort sporophytes, growing without setae, demonstrate a unique evolutionary pathway within bryophytes. Unlike moss sporophytes, which rise on slender stalks, hornwort sporophytes emerge directly from the thallus as elongated, horn-like capsules. These structures grow from a persistent meristem at the base, meaning the sporophyte continues elongating and producing spores over time. Their embedded connection to the gametophyte provides a steady supply of nutrients without needing a seta to elevate them. This direct growth allows hornworts to thrive in moist soils where sporophytes remain partly sheltered by surrounding vegetation. In early morning, dew collects along their surfaces, enhancing spore release as capsules split open. Though small and often overlooked, these horn-like forms contribute to the biodiversity of damp forest floors. Their persistence in select habitats mirrors a broader truth in bryophyte ecology: species persisting where larger plants cannot. Species persisting where larger plants cannot highlight the quiet dominance of bryophytes in harsh or overlooked environments. Mosses and liverworts thrive on thin soils, exposed bedrock, decaying logs, and shaded ravines, places where vascular plants struggle to gain a foothold. Their minimal nutrient requirements allow them to exist on dust, mineral films, and tiny fragments of organic matter. They absorb water directly from rainfall, mist, and dew, eliminating the need for extensive root systems. This independence lets them colonize rooftops, cliffs, tundra, and forest shadows. By softening surfaces, retaining moisture, and stabilizing microhabitats, bryophytes pave the way for future plant communities. Their ability to endure extremes makes them the quiet foundation of many ecosystems. And from these resilient survivors, the deep stillness of the forest emerges, leading us toward the final reflection of continuity and calm in the concluding facts to come. Bryophytes shape forest successions in ways that are both subtle and deeply influential, guiding ecosystems through transitions that unfold over decades or centuries. When they settle on bare soil, dead wood, or newly exposed rock, their tiny leaves and stems begin to hold moisture, capture nutrients, and create the first thin films of organic matter. These soft green layers prepare the ground for lichens, grasses, seedlings, and eventually entire forests, building the earliest foundations of life in places that would otherwise remain barren. What seems like nothing more than a delicate carpet is actually the quiet architecture of ecological renewal. Their presence softens light, regulates humidity, and slows erosion, creating calm, stable microclimates where other organisms can thrive. And as these moss beds gradually thicken, they become stepping stones for the next wave of forest species, turning silence and softness into the first chapter of a flourishing woodland. This slow guidance leads gently into how moss carpets respond after storms. Moss carpets calm the forest after storms in a way almost nothing else can. When heavy rain falls or wind scatters branches across the ground, it's the moss layers that soak up excess water, cushion falling debris, and stabilize disturbed soil. Their poikilohydric bodies swell with moisture, becoming soft, spongy blankets that prevent erosion and shield fragile seedlings from the sudden shocks of shifting weather. In the softened silence that follows a storm, These green mats hold onto droplets the way a memory holds onto a quiet moment. They shine faintly in the returning light, releasing moisture back into the air slowly, like a long exhale. This gentle return to stability creates safe pockets where insects shelter, where spores settle, and where roots can take hold again. The forest breathes deeply through its moss, finding balance after turbulence. And within this calm, another power reveals itself. The water stored inside moss delaying drought stress long after the storm has passed. Water stored inside moss delays drought stress in forests by creating reservoirs far smaller than any visible pool, yet far more dependable. Each moss leaf, no matter how small, is built from rows of hollow or absorbent cells designed to trap liquid like tiny cisterns. When rain or fog arrives, bryophyte carpets swell, storing water between their layers, inside capillary spaces, and throughout their intertwined stems. Over time, they release this moisture back into the ecosystem in slow, steady pulses, keeping nearby soil cooler and more hydrated than the surrounding ground. During dry spells, seedlings near moss beds wilt less quickly. Insects find refuge in damp pockets, and even the air just above the moss retains a thin veil of humidity. This slow release has shaped countless forest rhythms, letting life continue calmly even when the weather grows harsh. And it's within this stored water and steady resilience that we begin to understand the quiet strength of plants unchanged for millions of years. The quiet strength of plants unchanged for millions of years can be felt in every bryophyte cushion, in every thread-like stem that persists without roots, flowers, or complex tissues. Their survival strategy is not force but flexibility. They allow themselves to dry, to shrink, to go still for months, then revive fully with the simplest touch of moisture. Their genetic simplicity hides an evolutionary resilience that predates forests, predates insects, predates the rise of towering trees. When you look at a patch of moss on a log or a stone, you're seeing a lineage that has endured ice ages, drought cycles, shifting continents, and countless storms, all without needing to change very much at all. Their quiet existence is a lesson in softness as survival, patience as power, and adaptation through calm acceptance rather than rapid transformation. And this ancient steadiness leads naturally into the final truth: the gentle continuity of bryophyte life. Holding forests together, the gentle continuity of bryophyte life holds forests together through cycles far longer than human memory. They anchor soil in mountain ravines, weave soft networks across fallen wood, cradle fog on shaded stones, and knit moisture into the air in ways that keep entire habitats from unraveling. Their presence cushions the transition between seasons, giving forests a quiet foundation during floods, droughts, growth spurts, and long winters. Bryophytes create stability not through size but through constancy. Year after year, they remain close to the ground, absorbing what comes, releasing what's needed, and offering shelter to life forms as small as mites and as large as towering trees whose seedlings depend on moss-rich soil. In this continuity, forests find balance, held together by plants so small we often walk past them without noticing. And yet, it is these soft green threads, ancient and enduring, that keep the forest breathing in steady calm. As we reach the end of this quiet walk through the world of bryophytes, take a moment to notice how your breathing has settled into something slower, something softer. The forest we've been moving through together isn't one of towering trees or dramatic cliffs. It's a world made of tiny leaves, delicate threads, and slow, patient rhythms. A world that keeps its beauty close to the ground. Bryophytes ask nothing from us. They don't rush, they don't demand, They don't worry about outcomes or goals. They live by absorbing whatever the forest offers. A little light, a little shade, a passing drop of rain, and in return, they build micro-worlds filled with moisture and shelter, nurturing creatures that most of us never see. They remind us that life doesn't always need to be big or loud to matter. Sometimes the smallest, quietest forms hold the oldest wisdom. As we explored their lives, how they breathe at night, how they revive after drought, how they anchor themselves to stone, how they cradle salamanders and soften rainwater, we stepped into a gentler pace of existence. Mosses, liverworts, and hornworts flourish in shadows, along stream edges, beneath fallen logs, and inside the forgotten corners of the forest. They show us resilience not through force, but through adaptability. They don't resist their environment. They shape themselves to fit it. And in doing so, they calm the land around them. If you picture a moss cushion now, softened by dew, glowing beneath early morning light, you might notice how quiet the image feels, how steady. Bryophytes thrive by slowing things down, slowing water, slowing decay, slowing the shifts between night and day. They create stability in a world that is always changing. And maybe, for a moment, your mind followed that same path, slowing enough to feel a bit more grounded than before. Tonight, you don't need to remember everything we covered. You don't need to list species or picture every forest hollow. You can let the details drift away like spores on a soft breeze. What stays behind is simply the feeling, the cool calm of shaded stone, the gentle shimmer of moonlight on damp leaves, the hush that settles when moss absorbs the sound of rain. These sensations are more than imagery, they're invitations. Invitations to rest. Think about how bryophytes revive after losing almost all their water, returning from stillness to life with nothing more than a drop of moisture. You're allowed to do the same, to pause, to dry, to soften, to be still for a while, and then revive when the moment is right. Rest isn't a failure of motion. It's part of the cycle. The forest teaches that every living thing moves between activity and quiet, light and darkness, growth and rest. So if your day felt heavy or complicated, let the moss teach you something simple. Let everything settle. Let everything soften. Let your thoughts spread out like a quiet green carpet, each one finding its place without force. You don't have to hold anything tightly right now. As you drift towards sleep, imagine yourself lying in a dim forest hollow, your head resting on soft moss, the cool scent of earth rising around you. The air is humid, the darkness warm, the ground steady beneath you. No rush, no pressure, only the slow breathing of the forest, and your breath gently matching it. If this journey brought you any calm or comfort, you're welcome to return anytime. And if you'd like, you can subscribe when you wake. For now, the moss is here. The night is quiet, and the forest is ready to hold you. Rest softly, sleep deeply,